Well, welcome back. I hope you had a good break and got yourself some refreshment. We're going to continue the session on probability. This is now section 2, and we're going to start off with some examples. So let's go straight to example number 1. Example 1 here says, if a coin is tossed, describe the theoretical probability of it landing on heads. All right. This is a nice easy one to get us going. So we know we're going to toss a coin. That's our event. What are the possibilities for the coin? Well, it can either land on heads or tails. That means we have 2 possible outcomes. So with 2 possible outcomes, what is the probability of one of those events occurring? The one event that we're looking at is heads. So heads could happen 1 out of every 2 times. And by the same token, tails can happen 1 out of every 2 times. So to answer the question, you could simply go and write, it's 1 out of 2. That's a fraction. So we could write 1 out of 2, or if we wanted to convert that to a percentage, what is 1 out of 2 as a percentage? Well, for that to happen, we have to make our number out of 100. To convert 2 to 100, I'll have to times by 50 and do the same on top. So that would mean 50%. Lastly, I may have given you and asked you the question, write that as a decimal, and to write a percentage as a decimal, we simply divide by 100, and that would be 0.5. So any of those 3 answers would be a perfect answer for the question. Either a half, or 50%, or 0.5. All of those express the probability of the event of the coin landing on heads. Let's move on. This question says, describe an experiment to assess the statistical probability of tossing a coin. So we want to do a statistical experiment. So what do we need to do to set up an experiment? Well, for that experiment, we could say something like this. Take a coin and toss it 100 times. This is an experiment that we can do, and then measure the number of times the coin lands on heads or tails. So here we're setting up that experiment that we spoke about a little bit earlier, and we're testing the coin to see how many times it lands on heads or tails. Just a quick question here. How do you think that statistical probability would measure up to the real possibility if you assume that the coin is fair? Well, the more times you throw the coin, 100 times, 200 times, 500 times, you'd probably find the closer you'd get to that 50% theoretical probability that you calculated earlier. You know, if I threw the coin 10 times, for example, and we could actually go and do that experiment, we might get something like this. Heads, 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 tails, tails, heads, heads, tails, 4, 5, 6, 7, 8, and one more. Let's do it like that. That might be a 10-time throw. And you'll see what we got here was 1, 2, 3, 4, 5, 6, 7 heads. So 7 out of 10 times it landed on heads, and 3 times out of 10 it landed on tails. And you might assume from throwing the coin 10 times that this coin is not a fair coin, because it's 70% it's landing on heads, but only 30% it's landing on tails. But as you continue the experiment, and you do it 20 and 30 and 100 and maybe 200 or 300 times, or even 1,000, I know that seems like a long experiment, but you could maybe break it up into your class and try it and see if this works. You'd find that it would get closer and closer to a 50% chance, or what the theoretical probability actually states, 1 out of 2 times. Go and do it as an experiment. It's really worthwhile doing that to see if it works. Let's have a look now at question number 2, or example number 2. And it says, in the throwing of a fair die, what is the probability of getting a 6? Well, we know that a die has 6 sides, and we can get the values 1, 2, 3, 4, 5, or 6. So there are 6 possible outcomes for this event of throwing the dice. What would be the probability of one of those events happening? Well, for each one of them, it's a 1 out of 6 possibility. So we could get 1 out of 6 chance of getting a 1, a 1 out of 6 chance of getting a 2, and a 3, and a 4, and a 5, and a 6, all the way through. You see, we couldn't, no dice has maybe a 2 and a 2 and leaves out another number. If you had such a dice, well then that number would have another probability of getting that number being thrown. For example, if I had 2 2s on the dice and no 1, and I asked you this same question, and I said to you, what's the probability of getting a 2? Well, there'd be 2 possible outcomes because the dice has a 2 on 2 sides. So there would be a 2 out of 6 probability of getting a 2. But because the dice has just these 1 numbers, 1, 2, 3, 2, 1 through to number 6 on each of the side or the faces of the dice, we can just say that it is 1 out of 6 probability. And of course, the number we were interested in this case was the 6. So there we go, that's the 6. So to answer our question, it is a 1 out of 6 probability. Again, we can convert it to decimal or to percentage to 16.6%. We saw that on the calculator earlier, or a 0.16 as a decimal. Now, let's have a look at the next one, because this is where it gets a little more interesting. The question reads, what is the probability of getting an even number? Well, looking at each of these probabilities, we can see that there's an even number here, the number 2, and then also the number 4, and of course the number 6 is an even number. So there are 6 possible outcomes of throwing the dice, the values 1 to 6, but 3 of those probabilities would result in an even number. So I can write the probability now as 3 out of 6, because 3 of the probabilities would actually give me my answer of an even number. So 3 out of 6 we can convert back down to a half, and of course a half means a 50% probability. So if that dice was fair, which they said it was, there is a 50% chance of landing on an even number. All right. Let's go a little bit further. And the next one, question C, says a number less than 3. So let's go back and see what are the probabilities of getting a number less than 3. Well, the numbers that actually meet that criteria is the number 1 and the number 2. Because 3 is the number we're not allowed to be above. And of course, 3 is not less than 3, so we can't include it. So only numbers 1 and 2 would be valid answers or valid solutions in this case. So we'll be looking at 2 possibilities, the number 1 and 2, out of the 6 possibilities that we have of throwing the dice. So a 2 out of 6 probability is equal to a third. If I break that fraction down, and again, if we want to write this, and we should know how to convert to decimal and to fraction, a third as a fraction, as a decimal, is 1 divided by 3. Let's do that on the calculator. 1 divided by 3 equals, and there's the decimal, 0.333. And if I wanted to do that as a percentage, I'm just going to multiply by 100. So let's just look at that answer as well. It's 33.3%. So let's fill those in here. It's 0.33 or 33.3%. So the chance of the dice landing on a number less than 3, or 1 or a 2, is a 33% chance, or 33.3% chance, 1/3 or 0.33. And lastly here, we've got a fourth part, part D. The question comes in, what's the probability of getting a 7 with the dice? Well, the dice only goes up to the number 6. There's 1, 2, 3, 4, 5, or 6. So the number 7 doesn't appear on any of the faces. That means that you could never get a 7. It doesn't matter how many times you throw the dice. You could throw and throw and throw. It will never land with a side showing a 7, which in this case means an impossibility, or 0 or 0%. There we go. it can never happen, or we could even say, since the dice has 6 faces or 6 events, 0 out of 6 of those events would ever present as landing on a 7. Does that make sense to you? Are you seeing how this is starting to work? How we are taking the possible events that we could have and looking at the actual events that we do have and using that to express a probability. Also, I'm hoping you're realizing that chance is not just any old number. It's a specific value that can be mathematically calculated, as we've seen. Let's go on to the next section now. So we've got example 3 coming up. And now we're going to work with a standard pack of cards. Again, the questions in your exams will often like to use things like cards, so you need to be familiar with the card pack. Now, let's quickly run through what is in a pack of cards. I'm sure you're familiar with the terms hearts and spades, as well as diamonds and clubs. These are what we call the 4 suits of a pack of cards. A standard pack of cards has 52 cards in it, and then an extra 2 cards are usually put into a pack, and those cards are called jokers. Usually when it comes to probability, we remove the jokers so that we just work with the 52 cards. Those 52 cards have 4 suits: the diamonds, the clubs, the hearts, and the spades. Of those suits, each suit has 13 cards in it. And those cards range in number from an ace to a 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have the jack, the queen, and the king, making up the 13 cards. Sometimes we refer to picture cards when we're talking about cards, and then we will be referring to the cards called the jack, the queen, and the king. At times, the ace is also included in the picture. So make sure you understand, if the pack has said picture cards, then they will tell you usually include the aces if they want to include those as the picture cards. So picture cards refer to jack, queen, and king, and sometimes the ace as well. And then we can talk about the red and the black cards, because remember, the diamond suit and the heart suit are red cards, and the club suit and the spade suit are black cards. So when you have questions, you need to understand those terms, and we're going to use those terms in the question that we're going to look at now. So here's example 3, and the question says, what are the chances of picking a red card from our pack? Well, we're starting off, we've got 52 cards. To know to know what probability there is of picking a red card, we need to know how many red cards there are. Well, the 2 suits that represent red are hearts and diamond. That means we've got 2 suits of 13 cards each. And 2 times 13 is 26. That means there are 26 red cards in our pack. So the chances of picking a red card would be 26 out of the whole pack of 52. All right, so here we have a fraction, 26 out of 52. Again, your teacher would probably not give you full marks if you answered and left the answer in this form, because they'd either want the expression as a percentage as well, or in a simpler fraction. And we always need to simplify our fractions to the lowest possible fraction that we can. Well, 26 and 52, we actually have the number 26 can go into 52. And do you know how many times it goes in? Yes, the answer is twice. So I can reduce this fraction to a 1 out of 2, because I can divide by 26 on top, and I can divide on 26 at the bottom, and I get the answer 2 at the bottom. So it is a 1 out of 2 chance of picking a red card, or to express it as a percentage, 50%. This is a great way to leave your answer. Give the fraction as well as a percentage, and then there is no uncertainty in terms of your answer, and you probably get 100% for that question. So moving on to the next part, part B. And here they said what are the chances of picking a picture card? And they've actually told you what a picture card is. They've said it is going to be a jack, a queen, a king, or an ace. So we have any of those 4 cards can be picked. So we need to again determine how many cards in the pack will meet our criteria. Well, there is a jack, a queen, a king, and an ace for each of the suits, for the hearts, for the clubs, for the spades, and for the diamonds. So that means there are 4 suits that have 4 cards each within them that will meet our criteria in this question. So that means it's 4 times 4, which equals 16. So we have 16 cards that would be classed as picture cards in a pack of 52. So to express our probability here, we're going to say 16 out of 52. Again, you'll probably only get half the marks for the question if you leave it in this form. So let's reduce this fraction. Well, I'm going to start by dividing by 2 because I know that those are both even numbers and 2 will go into them. So 16 divided by 2 is 8 and 52 divided by 2 is 26. I still have even numbers, so I could divide by 2 again and reduce this fraction a little further, and it'll be 4 out of 13. Now 13 is a prime number, so that fraction is as simple as it can be. So expressed as a fraction, the chance of picking a picture card is 4 out of 13. But most cases we'd probably want the percentage, and to work out the percentage here we'd need to go and work out the percentage on our calculator. So let's call up our calculator and let's do a calculation to see what 4 out of 13 is as a percentage. Well, you'll type 4 on your calculator and divide it by 13. That gives you the fraction, which you can see over there, which you can convert to decimal. And if they'd asked you for a decimal, you could say 0.307, or if you wanted to round it off, 308. But to turn that into a percentage, I must take this answer and multiply it by 100. So we'll multiply by 100, and we get an answer of 30.769237. And normally for percentage, it is safe to just put 1 decimal place and round off to 1 decimal place. So we'll answer this as 30.8%. Right. So the percentage here, let's just write it in, is 30.8%. Great, so there we have our percentage. So to answer the question, the chance of picking a picture card out of a pack of 52 cards is a 30.8% chance. All right. Now they love these card questions and they have so many possibilities with them. So we're going to look at a couple more. I'm going to do C now, which is picking a diamond card. All right, so for a diamond, we need to know how many diamonds there are in the pack. And we said that there were 4 suits. Each suit has 13 cards, so that means that the diamond suit has 13 cards. That means we have a probability of 13 out of all the cards. So it's 13 out of 52. Again, we want to reduce this fraction, and let's go and check, does the number 13 go into 52? The answer is yes, it does. It goes in 4 times. So I'm going to divide by 13 and both sides, and I'm going to get a fraction of a quarter. Expressing that fraction again as a decimal is 0.25, or as a percentage, 25%. So the chance of picking a diamond card would be 25%. Now we're going to look at picking a number card of 2 to 9. So this is ignoring those picture cards that we had earlier. Remember in question B, we asked for a picture card and we found that there were 4 out of 13, or 30.8% chance of picking a picture card. We want to know what are the chances of picking a non-picture card, or a 2 to a 9. So that means there's a 2 to a 9. Let's count up quickly. There's a 2, a 3, a 4, a 5, a 6, a 7, a 8, and a 9. That means we have 8 cards. So 8 of the cards in any suit, how many suits are there? There are 4. So there are 8 times 4 cards, and that would be equal to 32. So 32 of the cards in the pack must be a number 2 to 9. So we've got 32 out of the total pack again, which is 52. Reducing that, we've got 16, if we halve it again, out of 26, or 8 out of 13. So there are 8 out of 13 chances to pick a picture card, or sorry, a value card of 2 to 9. And again, if we want to work out the percentage, we can go to our calculator, and we'll say 8 divided by 13. That gives us 0.61, or if we want it as a percentage, which is the usual way of leaving it, 61.5%. And let's just fill that in over here, 61.5%. Question E says, what's the chance of picking an ace? Well, how many aces are there in the pack? I'm sure you're getting the hang of this now and working with your cards. So here we go. How many aces? There are 4. 4 out of a total number of 52. That's 2 out of 26, or 1 out of 13. And again, I can turn that into my percentage. So 1 divided by 13, let's just clear that, 13, and we'll multiply it by 100 and express it as a number, 7.7%. 7.7%. And then the last one here says, what is the chance of picking the Queen of Hearts? Well, there is only one Queen of Hearts in the entire pack, so that means we've got 1 out of 52 chances. All right, and to calculate this percentage, let's just go back to the calculator one more time, and 1 divided by 52 is equivalent to, and we'll multiply that by 100, and that's 1.9%. So let's just close down there again. So this equals 1.9%. Now, before I close off these examples, I'd like to just show you something else with regards to these. If I said to you that we wanted to work out the percentage of the picture card, and let's just go back to that example. It was here, number B. We found out that the picture card was 30.8%. So I'm just going to write that at the bottom here, just to show you something on how you can calculate things quite quickly. We said that the picture card was 30.8% chance of being picked. What if I then said to you, what is the chance of not picking a picture card? Well, remember that the whole pack makes up what percentage? That's right, 100%. So if the picture cards make up 30.8%, then the non-picture cards would make up, correct, 100 minus the 30.8%. That would leave us with an answer of 69.2%. So we can express the probability of one event and then express the event of that thing not happening by subtracting it from 100%. The two always must add up. Remember when we said earlier, for example, with our dice, all the probabilities have to add up to 100%. If they don't, we haven't actually considered every option in our probability. So if I said to you that picking a picture card was 30.8% and then asked you what's the chance of not picking a picture card, you simply take the 100, subtract the 30.8%, and then you'll find the chance of it not happening. So the chance of an event happening is 100 minus the chance of the event not happening. Does that make sense to you? Well, that would help you, for example, in our card questions. If you had one event and you had the opposite of that event, you could simply take the answer to your previous question. Obviously, you'd hope that that answer was correct. But then you could subtract that percentage and find then the percentage for the event not happening. Great. We're going to take another short break, and then we'll be back to complete this section on probability.